Welcome to another video. This is still under general mathematics lesson. We are looking at diagonal method of finding the determinant of a 3 by 3 matrix. So consider a square matrix of that 3 by 3. We use letters to illustrate before we go into numerical problems. The matrix A is equal to what? A11, A12, A13, A21, A22, A23, A31, A32, A33. The determinant of A, that is det of A, is a short form of determinant of A. So now, determinant of A is equal to this. Now, what is the procedure? We take the sum of the product of the principal diagonal, which is A11 times A22 times A23, and you see black arrow, plus the off diagonal elements facing the principal diagonal, plus A12, A23 times A31. You can see the black arrow, then plus A21, A32 times A13. Look at it here. A11, A22, A23 plus A12, A23, A31 plus A13, A21, A32 minus the product of the sum of the secondary diagonal. This is the secondary diagonal. You see A13, A22, A31, which is this one. Now the dotted, you see, is the dotted arrows with red is showing the product of the secondary diagonal. A13, A22, A31 plus A12, A21, A31 plus A11, A23, A32. You can see it here. That is how we obtain the determinant of A. You can see that this method is faster than the other methods. If you can time yourself, you know. Now with this illustration, we are going to start solving problems. Problem 1, evaluate the determinant of 205, 463, 891. This problem is taken from JAM. Now the solution. You can following what we have done in the alphabetic illustration. You see that the determinant of this is what? 2 times 6 times 1 plus 0 times 3 times 8 plus 4 times 9 times 5, which is given here, minus the secondary diagonal 5, 6, 8. That's 5 times 6 times 8 plus 0 times 4 times 1 plus 2 times 3 times 9, which is this. And then you see that this is 1 times 6, 12, 0, 5 times 4, 20 times 9, 180. And then here, this is 5, 6, 30 times 8, 240. Look at it. Here is 0. Look at it. 9 times 6 times 9, 54. So 192 minus 294 will give us minus 102. Second problem. Find the value of k if the determinant minus 211, 21 k, 13 minus 1 is equal to 23. That means the value of this determinant is 23, but what value will be in the position of k for the determinant to be 23? So we are going to find the value of k. Of course, we still follow the same procedure by finding the determinant of this using our illustrative alphabetic illustration. Now, the principal diagonal is what? Minus 2 times 1 times minus 1. Look at it here. Plus 1 times 2 times minus 1.
Go fast.
I was saying that the principal diagonal is what? Minus 2 times 1 times minus 1 the up diagonal element facing that principal diagonal is what? 1 times k times 1, which is it? 1 times 2 times 3, which is this, minus the product of the secondary diagonal, which is 1 times 1 times 1, plus 1 times 2 times minus 1, which is this one, plus minus 2 times k times 3, which is this, equals to 23. So this is minus 2 times minus 1, this is 2. 1 times k times 1 is k. 1 times 2 times 3 is 6. Minus 1 times 1 is 1. Minus 1 times 2, sorry, plus 1 times 2 times minus 1 is what? Minus 2. Minus 2 times k times 3 is minus 6k, equals to 23. So if you open the bracket, you have what? 8 plus k minus 1 plus 2 plus 6k, because you open the bracket, the sign inside will change. That will give us 8 plus k minus 1 plus 2 plus 6k equals to 23. Then 8 minus 1 is 7. 7 plus 2 is 9. Now you have k plus 6k, which is 7k. You now have that 7k is equals to what? 23 minus 9. 23 minus 9 is 14. That means 7k is equals to 14, which implies that k is equals to 2. Meaning that if you substitute 2 here, you have a determinant to be 23. So you can see that with this method I call diagonal method is very fast. You don't need to do a lot of writing, like in Cyrus method where you have to repeat the first two columns of the determinant. As you repeat the first two columns of the determinant. That's the Cyrus method. You don't go about doing that. Here you go straight and take the product of the diagonal and the adjoining the up diagonal element, both ends, and then you subtract the same thing from the secondary diagonal. You have your determinant very fast. Thank you for listening.